On today's class, we'll be looking at an aspect of Utme chemistry, which is titled Solutions and Solubility. Okay, so let us understand the meaning of the word solution and what is the meaning of the word solubility. A solution is an homogeneous mixture of two things, because I believe by now you understand that there's something called mixture. We have what is called element, mixture, and also what compound. Okay, when elements combine together chemically, they tend to form a compound. But mixture, the difference between a mixture and a compound is a mixture means combination of two things that can be separated by what? Via physical what? Via physical method. Physical means, for instance, you have a mixture of sand and water. A mixture of sand and water can be separated because you know by the virtue of the fact that sand is insoluble in water. That's what we want to learn under solubility. So you can see that there's a close relationship between solutions and solubility. Now, your sand plus water will give you a mixture. Okay? When do we call a mixture a solution? When do we call a mixture a solution? Because there's a distinction between a mixture and what a solution is. So when you have a mixture of sand and water, this mixture can be separated by physical means. Okay? And how do you separate that? You can actually separate that by what? By decantation. Okay? By decantation, you can separate the mixture of the sand and the water. Okay? Now, let's come back to what solution is. So one thing we have derived so far is that a solution is a form of mixture. Okay? Now, two things make up a solution. Two things make up a solution. The first thing is what you popularly known as what? Solute. And the second thing is what you popularly known as what? Solvent. The first thing is what popularly known as solute, and the second thing is what popularly known as what? Solvent. So we can actually formulate a simple equation to say that your solution is equal to your solute and is equal to your solute plus what? Plus solvent. Okay? But when is a solution going to be called a mixture? A solution will be called a mixture when that mixture is said to be what? Homogeneous. When the mixture is said to be what? Homogeneous. So when do we say a mixture is homogeneous? We say that the mixture is homogeneous when the solute and the solvent, when they come together in the same word, phase. When they come together in the same phase, that is, the solute is getting to interact with the solvent, okay, such that the two things now come together to now exist in a single word, in a single phase. To exist in a single phase, they say that that combination of the solute and the solvent will give you what? A solution. For instance, if you look at what sand and water, when you mix sand and water together, you know, this does not even need your chemistry knowledge. When you mix sand and water together, you know that sand is not going to dissolve in water. In that case, you cannot call that a solution. You can only call that a what? A mixture. And they can ask you, is that an homogeneous mixture? No, that is not an homogeneous mixture, because when you look at it, there's a phase difference. The sand is going to be at the bottom of the beaker or whatever container, while the water is going to be at the what? At the top. So there's a difference in what? In phase. So because there's a difference in phase, that's not going to be called, that's not going to be homogeneous. That is not going to be called what? Heterogeneous. So that is just an ordinary mixture. It is not a solution. But let's look at this. Salt and water. Salt and water. When you dissolve salt in water, by the virtue of the fact that salt is, when I talk about salt, I mean a normal table salt. By the virtue of the fact that a normal table salt is soluble in water, when you dissolve normal table salt in water, what you are going to get is not a mixture now. What you are going to get is a what? A salt what? Solution. What you are going to get is a salt solution. So this is not a solution. This is not a mixture. It is also a form of mixture. But what form of mixture? it is an homogeneous mixture. It is an homogeneous what? Mixture. So we have seen that there's a distinction and similarity between solutions and mixture. Solution is a form of mixture that is said to be what? Homogeneous. Okay? That is said to, it is homogeneous. That is, the solute and the solvent agree to, they exist in the same world, in the same phase. They exist in the same phase. Okay? So now, that's what that's what a solution is. Now, most times there's always a misconception as to what a solute is and as to what a solvent is. For the purpose of JAMB UTME chemistry, we believe that the solute is the substance that is being dissolved. For instance, the salt, it is the substance that is being dissolved, while the water serve as the solvent, as the what? Dissolving medium. As the what? Dissolving medium. So the solvent is the dissolving medium, while the solute is the what? While the solute is the substance that is being what? Dissolved. But the solvent serves as the what? Dissolving what? Medium. Okay? Now let's continue. The extent as to how the solute tends to dissolve in the solvent is what is termed as solubility. That is the extent. For instance, now, you know that if you dissolve, let's say, salt in water, the salt is going to dissolve in water, okay, to give you a salt solution. But let's assume you want to dissolve something like salt in petrol. I can tell you that you can go and try this experiment. Salt is not going to dissolve in petrol. Salt is not going to dissolve in petrol. We are going to look at that. Why is it that salt cannot dissolve in petrol? Okay? Why is it that salt cannot dissolve in petrol? Now, what you see is that salt is very, very soluble in water, but salt is not as soluble in what? In petrol. Another thing is that, in fact, even if you have a mixture of, alcohol in water, alcohol is going to dissolve in water. Alcohol is going to dissolve in water. Okay? Why is it that alcohol can dissolve in water? We are going to look at that before the end of this class. Why is it that salt can dissolve in water, but salt is going to find it difficult to dissolve in something like a solvent like petrol? Okay? So the extent of solubility, the extent at which the solute tends to dissolve in the solvent is what is called what? Solubility. Is what is called what? Solubility. That's why if you look at the slide, the solubility is the ability to dissolve, the ability of a solute to dissolve in a what? Solvent. The extent at which the solute finds it easy to dissolve in the solvent is what we call what? Solubility. Another way of looking at solubility is it is the amount of the solute that is dissolved in a given amount of volume of solvent. I come again. The solubility is the amount of the solute that is going to be dissolved, that is dissolved in a given amount of what? Of solvent at a particular what? Temperature. We are going to call, I'm going to explain that. Why am I putting at a particular temperature? Okay? Why am I putting at a particular temperature? Now, why I'm putting that statement at a particular temperature is that because solubility usually depends on what? Temperature. It's not only temperature that it depends on. Solubility usually depends on what? Temperature. Now, let me just shed light to this. I've told you what solution is. Solution is the mixture of the solute and the solvent. The solute is the substance that is being dissolved. In the case of sugar and water, sugar is the substance that is being dissolved. Okay? Water is the dissolving medium. Okay? Now, in that case, I put it to you that most times, as an O-level student, you always believe that the solute has to be solid and the solvent has to be liquid. At advanced chemistry level, we believe that your solute can be anything. It can be in form of solid, it can be in form of liquid, it can also be in form of what? Gas. Likewise, your solvent also can also be in form of solid, can be in form of liquid, and also can also be in form of what? Gas. I'm going to give you an example of the common example of solutions that is something like this: sugar plus water. Sugar plus water will give you what? A sugar solution. The sugar is the solid, while water is the what? Liquid. Is the solvent, which is liquid. So most times you always believe that your solvent has to be liquid. Your solvent does not have to be liquid. Your solvent can take the form of solid, can take the form of liquid, can also take the form of what? Gas. Your solute can also take the form of solid, can take the form of liquid, can also take the form of what? Gas. For instance, when you dissolve alcohol in water, alcohol being dissolved in water, the alcohol there is the solute. The water there is the what? Solvent. Alcohol as a solute is not a solid. It is a liquid. It is a liquid. Ethanol being dissolved in water to give you an ethanol solution. To give you an ethanol solution, okay? The ethanol there is the solute, which is in liquid form, while the water is the solvent, which is also in liquid form. Okay, so what I'm trying to say here is that don't always believe that your solute has to be solid. No, your solute can be solid, can be liquid, can also be what? Gas. Your solvent also can be solid, can be liquid, can also be what? Gas. Now let me tell you something. One of the topics we are going to look at is air. Air is a mixture of several gases. Okay, you have oxygen, you have nitrogen, you have some other trace. In fact, you have water vapor, you have some other things that are there. But for simplicity, we always assume that air comprises of two major things: oxygen and nitrogen. Oxygen 21%, nitrogen 79%. Though these are an approximate percent. The oxygen is about 20 point something. The nitrogen is about 78 point something. So water vapor, CO2, and some other things like that, they are also there. So air is a mixture of all of these gases. So if air is a mixture of all of these gases, the mixture, air is, you can see a question like that: is air an homogeneous mixture or an heterogeneous mixture? I put it to you that air is an homogeneous mixture. It is homogeneous because I said, what is the meaning of homogeneous? They exist in the same phase. The meaning of heterogeneous is that there's a phase difference. That is, when you pour petrol in water, for instance, when you pour petrol in water, you see that the petrol is not going to dissolve in water. The petrol will stay at the what? Top, while the water is going to stay at the what? Bottom. That means that the petrol is not dissolving in water. It is not a solution. Rather, it is just a mixture. It is, we say that it is an heterogeneous. Hetero means different. That is, there's a difference in phase. The petrol is at the top, the water is at the bottom. There's a difference in phase. Okay? So when you have that kind of thing, in that case, you cannot call it a mixture. You cannot call it a solution. You can only call it a what? You can only call it what? A mixture. So air is an homogeneous mixture of all of these gases. Air is homogeneous because when you look at air, there is no phase difference. All the gases are mixing together. Air is something that we all breathe in. There is nothing like the oxygen is separated from the nitrogen. We are not even seeing the oxygen. We are not seeing the nitrogen. All we know is that we breathe, we take in the air, we breathe out, and then we do our life to our day-to-day activity. So air, that's a UTME question. Air is dash. Is it an homogeneous mixture or an heterogeneous mixture? It is an homogeneous word mixture. Okay, and I've told you how to identify homogeneous and how to identify heterogeneous. Homogeneous means that they exist in the same phase, while heterogeneous means they exist in what? Different what? Phase. Okay, that is, in heterogeneous, the two things that are coming together, they are not mixing, they are not agreeing, they don't have compatibility. Petrol does not have compatibility with water. We are going to explain that. Why is it that petrol does not have compatibility with water, but something like sugar, salt, normal table salt has compatibility with water? We're going to look at that. Okay, so the extent as to how the solute tends to dissolve in the solvent is what we mean by what? Solubility. Okay, now what are the factors that solubility depends on? We are going to look at types of solutions. Okay, and we're also going to we're going to attempt questions on how do we solve solubility problems. Now, when I was defining my solubility, I made a statement. I said solubility is the amount of a substance. When I say substance, I'm referring to the solute. The amount of the solute that will be dissolved in a given amount of solvent. at a particular temperature. What does that mean? What that means is that your solubility depends. Your solubility depends on temperature. Your solubility depends on what? Temperature. So how does solubility depends on temperature? Solubility depends on temperature in what manner? This is the manner it depends on temperature. This is the manner it depends on temperature. For every an increase in temperature, whenever you raise temperature, what happens is that solubility tends to what? Increase. An increase in temperature will result into dash. Increase in what? Solubility, generally. Usually for solids. For solids, an increase in temperature will lead to an increase in what? Solubility. An increase in temperature them at a particular temperature. You might have that, okay, probably when you dissolve something in cold water, it does not dissolve very well. But when you dissolve it in hot water, it tends to dissolve. Something like coffee. Coffee does not dissolve very well in cold water. But in hot water, it dissolves very well. Why? Because of the temperature. So when you increase temperature of solids, generally, we believe that what? Solubility what? Increases. We believe that solubility what? Increases. So one of the factors that affects solubility is temperature. It's not only temperature that affects solubility. We still also have other factors like pressure. Okay. So how does pressure affect? Now, most times when we talk about pressure, we're only referring to gases. We believe that when you increase the pressure of a gas, the pressure of a gas in a solvent, we believe that the solubility will also increase. And take note, pressure does not affect solubility of temperature. Pressure does not affect solubility of solids. Pressure only affects solubility of what? Gas. Because when we're talking about pressure, we are talking about gas. It's usually for gases. Okay? Pressure usually affects solubility of gas and not that of what? Temperature. Not that of solids. But when you increase temperature of solid, when you increase temperature for solid, their solubility tends to what? Increase. Okay? Now, let's look at another part of the let's look at another part of what solution is. Okay, then before we start looking at the different types of solution, now let's look at we see that we have three types of solution that you are expected to know. The first one is what we call unsaturated. The second one is what we call what? Saturated. And the third one is what we call what? Super what? Saturated solution. These are the three types of solutions that you are expected to know. Unsaturated solution, saturated solution, and then super what? Super saturated solution. Now, when do we say that a solution is unsaturated? And when do we say a solution is saturated? And when do we say a solution is super what? Saturated? Okay, let's go. Now, unsaturated. This is how I explain unsaturated and saturated for students. Look at this. Let's assume, like I said, there's something called solubility. And I said solubility means what? The amount of a substance that can dissolve in a given volume of what? Solvent. Okay? Now, let's assume you have a certain volume of water. That volume of water can comfortably dissolve 100 grams of sugar. 100 grams of sugar can comfortably be dissolved in, say, 1 liter of water. Now, when you have a solution of 100 grams of what? The sugar in 1 liter of what? Of water. That is the normal capacity of the water. That is what it can dissolve. That type of solution that contains as many solutes that it can dissolve at that temperature a solution that contains as many solutes that it can dissolve at that temperature, we call that solution is saturated. When we say something is saturated, let me give you another illustration. A class. In your class, let's say a class can only contain 50 students. That's the normal capacity of the class. If you put 50 students in that class, you know that the capacity of this class is 50. I put 50 students in that class, I can tell you that you can see that that class is said to be what? Saturated when you put 50. But if I know that the capacity of the class is 50, and I put 40 students there, can we say the class is saturated? No. The class is what? Unsaturated. That is, it is not yet saturated. That means that it can still hold up some more students in that class. But when you know that the capacity of the class is 50, you now put 60 students there. What is that going to be? That is going to be what? Super what? Saturated. Super, meaning excess. Okay? And what that means is that you are having excess of 10. You are having excess of 10. Now go and try this experiment at home. Take a certain amount of water in a cup and then start dissolving salt inside it. You know, when you add a pinch of salt, you realize that to dissolve. Continue adding more salt. Continue adding more salt. It will get to a point that water cannot hold up any other salt again. When it cannot hold up any salt again, such that you are now seeing that some salt are now left undissolved, that you are now seeing salt at the bottom. When you take a certain cup, pour water inside it, a certain amount of water, add a small drop of salt, you see that thing, the salt is going to dissolve. You are not going to see it again. At that point, the solution is saturated. When you add more salt, it is still taking it. It's still dissolving. It's still dissolving in that manner. Okay? It is moving. It's not going to be moving from unsaturated up until what? It becomes what? Saturated. If you continue adding it, you will add it up to a point that the salt cannot hold up, cannot dissolve any more solute. It cannot, the water, cannot dissolve any more solute. That means in that case, the salt is now going to what? We use the word crystallize. We use the word what? Crystallize. That means that the solute is not going to crystallize out of the solution. You are not going to see it at the bottom. You see that some of the salt is not dissolved. In that case, we now say that the solution is said to be what? Super what? Saturated. It's said to be what? Super what? Saturated. Now let me give you, now because you are writing JAMB UTME, JAMB UTME does not test what is a super saturated solution, what is a saturated solution. But nobody, this is objective exam. So how do you see questions on that? Let me show you what you are going to see in your exam. You are going to see on the day of your exam, live and direct. You will see a question like this. The solubility of a solid. The solubility of a solid at 25 degrees Celsius in water is 30 grams per 100 grams. They will now give you some options. They will now say that they will give you some options. They will say, okay, let's say 20 grams per 100 grams of solution. They will ask you, is it unsaturated? They will now give you another one at the same temperature, at that same temperature, 40 over 100 grams, 25 grams over 100 grams, and then let's say 15 grams over what? 100 grams. This one are quite easy. Now, if this is the normal solubility of the salt, of the solid in that water, 30 grams per 100 grams. What this 30 grams per 100 grams means is that this thing can dissolve 30 grams of the solute, which is the of the solute, can comfortably be dissolved in what? In 100 grams of the what? Solvent. Okay? This is what it can normally dissolve. Now, when you now have 20 grams of the solute in 100 grams of the solvent, is that saturated or unsaturated? That is clearly what? unsaturated. That is clearly what? Unsaturated. Now look at this. 40 grams or 100 grams. You can see that this now means that what? You have more solute than it can hold at that temperature. That is, you have more solute that it can hold at that temperature. That means that this is now what? Super what? Saturated. But look at this. Look at this. These are less than what it can hold. These two still falls under what? On what? Unsaturated. This thing still falls under unsaturated. This thing still falls under what? On what? Unsaturated. Do you get? This thing falls under what? Unsaturated. So we are still going to look at more and more questions like this. Okay? We are still going to look at more and more questions like this. So let's now take it a step further. So I've explained what unsaturated is, what saturated is, and what supersaturated is. So let's now look at what do we mean by how do we calculate solubility? How do we calculate what? Solubility. So I go. Like I told you earlier on, solubility means amount of solute that you can dissolve in a given amount of solvent. Okay? Solubility is the amount of solute that you can dissolve in a given amount of solvent, okay, at a particular temperature. Now, I tell people, when you want to solve solubility, there are several ways you can solve your solubility. Your solubility can be expressed in moles per dm³. Your solubility can be expressed in what? In moles per dm³. That's the unit. That's one of the units. If you are expressing your solubility in moles per dm³, it means that your formula of solving the solubility will be what? Number of moles of the word solute over volume of what? This in what? In dm³. Well, if you are solving your solubility in moles per dm³, what this means is that number of moles of solute over the volume of the solvent or the volume of the solution in what? In the volume of the solvent in dm³. Okay. Now, for those that know from our preliminary chemistry, we know that to get number of moles you'll be getting by mass over what? Over what? Molar mass. Mass over molar mass. That's how we get our number of moles. Another way you can express the solubility is in gram per dm³. So for gram per dm³ now, what would this now mean? It will mean what? Mass of the what? Solute in what? Gram over volume of the solution of the solvent in what? dm³. Now, another thing I want you to note is that most times they will not give you the volume in dm³. They will give you the volume in cm³. So they are going to use this conversion unit that 1000 dm³ is equals to what? 1 dm³. So what this basically means is that if you want to convert your cm³ to dm³, just divide by what? 1000. Okay, just divide by 1000, and then you're going to get what your solubility. So before you start solving solubility problems, you have to understand what unit is a question requiring you to solve the solubility. What unit is it? Is a question requiring you to solve the solubility. So let's look at this question. Let's look at this Utme question. The question says, calculate the solubility in moles per dm³. That's the first thing you have to watch out for. In what unit do they want you to solve the solubility? Calculate the solubility in moles per dm³. Calculate the solubility in moles per dm³ of 40 grams of SO4 dissolved in 100 grams of water. We are asked to get the solubility moles per dm cube of 40 grams of CuSO4, that's copper sulfate. It dissolved in 100 grams of water at 120 what? Degrees Celsius. So the question will give you that Cu is 64, S is 32, O is 16. So we are asked to get the solubility in moles per dm cube. So let's look at the solution. So look up. Your solubility in moles per dm cube means the number of moles of the what? Solute. Okay? Divided by the volume of the solvent. The volume of the solvent in what? In dm cube. Okay? So you can see that in the problem did not give us the number of moles of the solute, which is CuSO4. So we have to obtain what the number of moles of the solute is. So we know that number of moles equals to what? Mass over what? Molar mass. So in this problem, we have been given the mass of the copper sulfate that is being dissolved. So we know that. But we don't know the molar mass. Thank God we are given the formula, so we can get the molar mass. So what will now be the molar mass? The molar mass will now be what? Copper is what? 64 plus sulfur is what? 32 plus oxygen is what? 16 times what? 4. So what do you have? 64 plus 32 plus, this is I think 64. Okay? 16 times 4 will give us 64. So when you add that together, that will give you what? 160 gram per what? Gram per mole. That's the unit of molar mass. So what will now solve the number of moles now? The number of moles will now be the mass of the solute, 40 grams, divided by the molar mass of that, 160 gram per mole. When you divide that, my number of moles will now be, okay, so we have 40 divided by what? 160. 40 divided by 160. So we have what? 0.25 what? Moles. So we have gotten the number of moles of the solute. Now look at this volume of the solvent, because the question says would you find the solubility in moles per dm cube, volume of the solvent. Now in this question, what is the solvent? Water. But if you look at this problem very well, this problem is not saying anything about volume of water. Rather, the question is telling us that this 40 grams of CuSO4 is dissolved in 100 grams of water. So how do we now get the volume of water? That's where the problem is. So to get the volume of the water, we now do this. To get the volume of the water, watch. Now, from your physics, you know that density of water is said to be what? 1 gram per what? Cm cube. Density of water is said to be what? 1 gram per cm cube. That is, if you have 100 grams of water, 100 grams of water is equivalent to what? 100 cm cube of what? Water. So that 100 grams of water is equivalent to what? 100 what? Because the relationship is 1 to 1. It's equivalent to what? 100 cm cube of what? Water. So we cannot get the volume in dm cube now. And I told you that to convert cm cube to dm cube, all you need to do is to divide by what? 1000. So the volume in dm cube is what? 100 over what? 1000. So what do you have? 0.1 what? dm cube. 0.1 what? dm cube. So we can now get our solubility. Solubility in moles per what? dm cube. It now means the number of moles that we have solved for, number of moles of the solute, which is 0.25 moles, over the volume of the solvent, 0.1 dm cube. So what do we have? When you divide that, I think that should give you 2.5. That should give you 2.5. So you have 2.5 moles per what? Per dm cube. 2.5 moles per 2.5 moles per dm cube. So that is what so that is a general overview of what for that's the general overview of what that's 2.5. That's 2.5. Okay. That's 2.5. So that's a general overview of what solubility. So pay attention to the fact that now, for instance, now I can give you this as assignment. Go and attempt this solubility in gram per dm cube. I can also say find the solubility of this guy in gram per dm cube. In that case, now all you need to do is mass of the what? Solute in gram over the volume of the solvent in what? dm cube. In this case, the mass of the solute in gram is 40 gram over the volume of the solvent that we have solved in dm cube, 0.1 dm cube. So that will give you what? 400 gram per what? dm cube. I've already solved the question. So you have to always look out for what the unit of the question is talking about. Is it in gram per dm cube or is it mole per dm cube? So in the next class, we are going to take it on to suspension, other forms of solutions, and then we take it on from there. Thank you for having me.